Hello everyone. This is Priya from Aarna Networks. Thank you for taking out your time and being here today. Today we will show you how to orchestrate cloud network functions on public cloud through AMCOP, and also we will show you how to install AMCOP on public clouds. As I say every time, we would love to hear your queries and questions. However, request all of you to post your queries, post the webinar, as I will be running a short question answer session at the end of it. So if you have any questions, just write to me or you can ask directly. And if you miss anything, don't worry, I will be sending an on-demand recording. So let's not delay and start the webinar. So today, let me introduce you to Rajendra, who is the lead engineer at Aarna Networks. He has worked extensively on cloud technologies, Linux, storage system, processor architectures, and embedded systems. So hi Rajendra.
Hi Priya.
Hi, how are you?
I'm doing good, thank you.
Okay, I will stop sharing the screen. You can start your session.
Sure, I'll do that. Let me share my screen.
Yeah.
Okay. So can you see my screen, Priya?
Yeah, I can see.
Okay, let me just start. Hello everyone. My name is Rajendra Mishra. Warm welcome to everyone. And today we will be talking about CNF orchestration on public clouds. So at a high level, we will basically deal with what is the architecture of the tool that we use for deploying the CNFs, the public clouds that we operated on, and some of the challenges that we faced, and a little bit of a technical details on what were the commands used and how we proceeded with the process of orchestration. So let's start off with the description. So what are the different type of clouds? So I am categorizing them in three categories right now. So there is public clouds, which is primarily the Microsoft Azure, Google, and AWS, and there are other public clouds that are there. And then we have the private clouds, which is we can create a cluster of a couple of bare metal servers and deploy, for example, OpenShift on it. And then we can use that for orchestration of any of the Kubernetes application. Third category is a hybrid cloud, which is primarily like part of it is in on your premise and the other part is in the public cloud. So in this session, we will focus primarily on the public clouds, and in the public cloud also, we will cover only the Microsoft Azure, the Google, GCP, and the Kubernetes engine, and the AWS EKS. So moving on to the next slide. So what is the CNF orchestration? So I'm just giving a high level overview of what is the idea of orchestration. So typically we have these CNF packages. These are net telecom domain network functions, which contain the logic for routing and different functionalities that is being provided by the telecom operator. And these packages, when we want to onboard them to any of the Kubernetes edge cluster, so there is this tool that sits in the middle, as we see in the diagram, which is called as an orchestrator. And the orchestrator will pick up the CNF packages and it will deploy them on one or more edge clusters, the Kubernetes edge clusters that are there. These clusters could be different public clusters or they could be private. As I said in my previous slide, any of these clusters in different categories could be there. Now the orchestrator internally, like as we see, there are small boxes within it. It does like these functionalities. In addition to that, it does many more things that are there. I just listed some of them for reference. So for example, it will register the cloud. It will create it is also a hardware platform controller where it is aware of like different functionalities of different cluster. It does like network configuration management, application scheduling, resource synchronization, monitoring. All these stuff are done typically by the orchestrator. So it will take the CNF, and the way to interact with an orchestrator could be either through REST APIs, or we can use a command line tool, or we can have a web interface. So in this particular meetup session, I will be primarily covering this tool from Aarna Networks, which is AMCOP, Aarna Networks multi-orchestration, multi-cluster orchestration platform. And these clusters, they could be running in at different location, or they could be at the same location. In our scenario, we will be using public cloud, and we'll fix the location, and we will deploy a sample CNF. So in our case, like we are taking the free 5G CNF that is publicly available. We take that application and we deploy it onto different clusters. So going to the next slide, what exactly is the AMCOP? So there is a more detailed version of the internals of AMCOP and what are the different functionalities that are provided. You can go over to this YouTube link, which talks about the 2.0 version of AMCOP. What are the new things that are there? In general, just for our reference and just to complete this discussion, I will talk at a high level what all things are being used in as a part of our deployment. So this AMCOP orchestration tool, it's first of all, it is all open source, and all the components are like available for download, and you can download it and deploy it on your own. It does like lifecycle management for the CNFs that are there. It can do closed loop automation for 5G network services, edge, and then all the edge computing applications that are there. In general, like this is the tool, as I showed in the previous diagram, that fits in the middle, where it can take a CNF package and then it can deploy and do a lifecycle management of the CNF package that is deployed. And as a part of this package, we are also we also involve the openness MCO. This is basically part of this entire package, which is used for intent-based orchestration and then day zero configuration of the CNF. Then there is this controller design studio, the CDS component in ONAP, which we use for day one and day two configuration, and then lifecycle management, which is also a part of this AMCOP deployment. And Google CDAP and some other open ONAP components that are there, they are also used for doing some analytics. And as a part of this package, we are using a lot of CNCF projects, Istio, Prometheus, and Fluent and Jaeger and all. These are used basically for creating this entire tool and making sure that we can provide the necessary functionality of orchestration. On top of that, from Aarna Networks, we have some value add products like slicing, so which is like a completely new feature in 5G, where you can slice the networks and give like dedicated chunks to the user. Then ORAN, non-RTDIC, and NWDAF, all these components are there. These are like value added features that are added on top of the existing open source tools that are available. As we see on the diagram on the left hand side, we can communicate with this Aarna user interface either through a command line tool, or we can do REST APIs, or we can do it through the browser. So for this session, we will be primarily using the browser based access to the AMCOP tool, and we will showcase how we were able to deploy a fully functional free 5G CNF onto different public clouds. So going to the next slide, so a little bit of a diagrammatic view of how the orchestration setup looks like. So on the left hand side, as we see, there is a big cloud, and in that we are creating two boxes. Each of the box is a Kubernetes cluster. These are independent clusters. One cluster we are using for deploying the AMCOP tool itself, which will have the AMCOP, AMCO, and other components. I haven't shown all the components here, but it will have all the necessary components that are required for basically doing the orchestration. On the right hand side, we see this other box, which is again a Kubernetes cluster, and that's where we will deploy the CNFs that are there. And these two clusters should be able to talk to each other. In this particular diagram, they seem to fit in a same location. In real life scenarios, we can have them at a different location, or we can also have multiple of these K8s clusters, which are deploying either the entire CNF or parts of the CNFs in the cluster. So the one on the right hand side, we call it as a edge or the target cluster. And this is where the CNF that we are choosing, that I will showcase in a while, is a free 5G CNF, which basically gives the free 5G functionality. And we will show how we were able to deploy this entire CNF onto the public cluster. So we have to make sure that there is a connectivity between these two clusters. And so we, in our setup that I am going to present, we created a subnet, a subnet on the public cloud, and then made sure that these two clusters, they are on the same subnet. So that way, pods on one cluster, they are able to talk to the pods on the other cluster. Other thing that we have to basically a little bit of a emphasis I want to give is there is these CNFs, typically all the telecom CNFs, they require multiple network interfaces. So for example, for virtual firewall, we need like two or more than two interfaces. And in Kubernetes, the default option is to give only a single interface. So just to overcome that, we had to deploy additional CNIs, which basically add this functionality of creating multiple network interfaces from a single pod. And this functionality is primarily required on the target cluster, where we are target or the edge cluster, where we will be deploying the specific CNFs. So this is like a high level overview of how the setup looks like, with the two clusters, one for deploying our tool and another for deploying the CNF that we are talking about. And then they are connected. They are all in a public or a private cloud setup. Now, going further, what are the challenges that we face in public clouds? So one major challenge is when deploying on a public cloud, that we do not have any control on the plugins that will be installed as a part of the node. So in a typical Kubernetes setup, you have these different nodes, and on these nodes we have these different software pieces that are running where we deploy the pods. Now, if we talk about, let's say, a Google Cloud or Google Kubernetes engine, the GKE, then in that, if we create the cluster using the GKE tools, then it gives you a very simplified interface where you can just issue one command and that will go and basically create different set of nodes, which are primarily VMs from the GCP. And on these nodes, it will deploy the necessary set of software, which will create the Kubernetes cluster environment. But the problem is, like, if let's say I want to have any additional plugins, now unless it supports those plugins through command line, I cannot add them, because all these nodes are managed by the public cloud provider. So this was one of the major challenge that we had, because some of these plugins CNFs, so let's say if we want to deploy the CNF, then they require multiple network interfaces, for example. And one mechanism for providing multiple network interfaces is another open source project called Multus, which allows you, it is more of a meta plugin, and it allows you to basically create multiple interfaces. As we see in this diagram, for a given pod, we can create H0 and net zero interfaces. It does like a little more than just creating interfaces, but okay, so there is, okay, I thought there is a question. So going back, let me just, so yeah, so basically this meta plugin that is there, we need to deploy it. And now if the public cloud doesn't allow us to deploy any plugin, then it becomes difficult to deploy some of the CNFs. So in that scenario, what we ended up doing was to take these VMs from the public cloud and then create our own cluster ourselves. And that way we have the ability to basically add and as many plugins as we want, and then build the cluster and deploy the necessary CNF on it. So that was one. In addition to that, like the general challenges are we have to make sure that the security access to the cluster is well protected, and it should not be publicly accessible. And then the cluster on which our AMCOP tool is running should be same as the edge cluster. So that way, they can talk to each other. So for that, we have to make sure that we have to create these two connect like clusters in such a way that they will fall in the same subnet. So going to the next slide. So this is the current state of all the clouds on the deployment of AMCOP on all the clouds. So as we see, like we have Google GCP. So I tried to uh, create a table that basically tells us like what is the current state of different on different cloud, what is the current state of deployment. So as we see on Google GCP and GKE, so the multus plugin is not supported. So as a result of that, we had to create two separate VMs and allocate these VMs and then tie them together, build our own cluster on top of it, and then use that for the deployment of AMCOP as well as the CNFs that are there that we were trying to deploy. And same is true for the Microsoft Azure. So currently in the roadmap, it is not there to support multiple plugins, multiple network plugins. So as a result, we have to do VM creation, and then on those VMs, we basically deployed the AMCOP tool as well as the CNFs. On Amazon AWS, the good thing is that the plugin is supported officially, and so we are right now working on it. And since this is all an open source project, and anybody can pick up and help us, so I would also request you all, if you are keen on collaborating on it, then it would be good if we can deploy it on the Amazon EWS on a native cluster, which is the EKS cluster. So currently, I have been able to deploy it by allocating VMs, connecting them together, and then deploying the CNFs using the AMCOP tool. So this is a little bit of what is the command line tool, just for our reference. Basically, in the Google Cloud, you can create a container cluster where you specify G Cloud container cluster name and then different parameters, how many nodes you want and what kind of functionality you want, the location and all, and it will create a cluster. And after that, you can deploy it using the standard deployment mechanism. So we did it using the Helm charts and the kubectl command. And similar, same is true for the Azure EKS, where again, you use the EKS command line tool to create a cluster and specify the different parameters associated for the cluster. And this will create a cluster. After that, you get the kube config. And then you can use Helm or you can use kubectl for deploying all the tools that we are basically the AMCOP orchestration tool that I'm talking about. And so on Azure AKS, like there are more mechanisms beyond the command line. They also support Azure Resource Manager templates. I'll talk a little bit about it after this slide. And so that kind of simplifies this entire process of deployment, where with the singles description, a JSON file, I can specify how I want to build my infrastructure. And it will allocate the necessary resources and do the deployments. We can specify some custom scripts. So that is slightly more advanced. Similar things can be done on Google and Amazon also, but I haven't been able to reach there. Again, I would request, like, if you are keen on collaborating or contributing on it, then you can contact us and we can take it further. Same as we see, the third command line is basically for creating the Amazon AWS cluster, which is, again, we specify the necessary parameters, like what region, and we want to give SSH access and cluster name and all, and it will create the cluster. And after that, once the cluster is created, then the mechanism for deploying is a standard, because these are all Kubernetes cluster and they conform to the Kubernetes specific standard, and we can use the same set of scripts for deploying on different clouds. So just a little bit of detail on Azure, since we worked on it, and I was able to create this Azure template for the deployment of this AMCOP tool, which will bring up this entire tool on the public cloud using a single click. So this particular template is for basically Azure Marketplace. So where we have this create UI definition. So I will show a small video just after this presentation, in which we can see how this entire process of bringing up this entire tool on a marketplace. And the marketplace is open. Anybody can log in and they can try, creating a cluster and deploying AMCOP on it, and it simplifies. In the background, these are the files that are basically making this job happen. And we have this create UI definition that will take some input parameters. Then main template, it kind of specifies what all resources do we require um, for this particular deployment. So in our scenario, we required like a virtual machine where we could run some scripts, and then we required a cluster. We required some network security groups and some tenants for basically accessing it. And so all the general, stuff that is required for deploying on a public cloud. So that has to be specified in the main template. And in the script, we can specify any custom script. So in our case, the custom script would be to download the AMCO and the AMCOP binary images from the internet, and then create an instance of it and deploy them, and eventually like create a service out of it and show me the IP address which we can use for logging into the tool. So this is like just a high level overview of how Azure templates look like and what we did in this entire exercise. So next I will just go to the AMCOP deployment video. Just stop the screen here and let me start the video. So Priya, you can see the screen, right?
I can see.
Okay, thank you. So yeah, so this video I created when we just go to the Azure Marketplace, and where I'm trying to showcase how using a single click you can do the entire deployment. We just have to pass a few parameters. So this is my starting screen. You can go to Azure Marketplace, search for AMCOP platform, and then click on create. So it will take you to the CNF or the deployment screen, where we will have to provide a few parameters. So it gives you the description and what we are doing, and some commands, additional commands that we have to run after the cluster is created. So yeah, these are the standard parameters. So creating a resource group, and then the region that we want to run this particular cluster in. And if for debugging or for any other purpose you want to log into any of the nodes, then the default name is Aarna, but you can change the name of the cluster, which is again some default value is there, but we can override that with some name that we want. And as we see, we've trying to change the default value to AMCOP plus. So it simplifies this entire process of creating all these resources and then deploying on that cluster. So all that is done using those JSON files and those scripts that I showed in the previous slides. So as we see now, it does some validation on it. This is like validating whether the parameters that we have passed are as expected, and do the basic validation, submitting it for deployment. So now deployment is in progress, and we will see slowly, like different resources will start coming up on the screen. Here we will have the resource, the type, and we can see like what is the current status of it. As we see, like the cluster is created, and as I was talking previously, in the main template we have to specify what all resources do we require to create. So this is basically creating those resources. So we have a network interface, then the cluster, and virtual network and network security group, public IP, which we will use for accessing this particular GUI for AMCOP. So I'll do a little bit of a fast forward here. So now once the cluster is created, then we have to run, we can access this cluster and see all the pods running by downloading the kube config, and so in this scenario we are extracting the external IP that we created. Now as we click on the external IP, this will take us, so the cluster is deployed, and we have like all the pods in place. And at this point, now we can access the AMCOP GUI, and we can use the GUI for basically onboarding the different CNF. So in this particular case, I am picking up the free 5G CNF, which will be deployed. So all this deployment is going to happen on another AKS cluster. So here we are registering the cluster, the additional cluster that we have. And we have to make sure that these clusters, they are in the same subnet group, so that, you know, this tool, wherever it is running, it should be able to access. So it does a check over here when we add the cluster and we add the kube config. So this is the config file for the cluster that we have added. And now we need to add the controllers. So these are like part of this orchestration tool, and we have to configure it so that we can register the controller, and which will be eventually used for the deployment of the CNF. So we're adding this service now, and yeah, so as a part of this entire process, the tool will internally connect with the target cluster, and then take the Helm chart. The stuff that we are providing is primarily the Helm charts for the free 5G, and the profile and all, which is primarily the configuration value, any configuration overrides that we want. We identify which clusters we want to use. So we can have like a large number of clusters, and we can select like which cluster we want to really deploy this particular CNF on. And as we click on the instantiate, at this point we see we are trying to see what all pods are running in all the namespaces. As we see, we have the Azure pods. Now we will click on instantiate, which will deploy the free 5G CNF onto the target cluster. So this is my cluster one, where our tool is running. We can see the components like MCO UI and middle end and MongoDB, which is used for storing all these configuration values. And this is my target cluster that is being created. All this is done by just a click of a button, which is there on the Azure Marketplace. And you can log into Azure Marketplace, and you can try it out. It has the details for what additional steps are required for accessing the cluster, and then you can go to the documentation present on Aarna website with details on how to onboard the cluster and how to configure it. So with this, I will come to an end, and if there are any questions, I can take that. Questions, comment, or feedback, all welcome.
Yeah, hello. Yeah,
Priya.
actually, I mean, you can either write it to me, or you can just ask Rajendra directly. We'll just give few seconds, Rajendra. Huh?
Sure.
Hi, can you hear me?
Yes.
Yeah, please.
Hi, thank you both for the presentation. Just a quick question regarding when you want to deploy services on edge clusters, right? And you want that the service running on a given edge cluster, you need a VLAN interface, let's say. You need that the CNI running on that edge cluster spin up a VLAN interface toward the, let's say, the wireless devices. How this platform handle with that?
So just for my understanding, I repeat the question. So you were saying that on the target cluster, uh, the services that we create, how do I get the public IP address? Is that what you meant?
Well, you're correct in the sense that talking about the target cluster, right? But imagine that you want to deploy a service in the target cluster, but you need a VLAN interface on the physical edge server, right? Just for an operator use case or something like that. If the Multus CNI that you install in the target cluster handling that, or is this something in progress?
So yeah, so basically, if we have, so currently the way we created the interface was using the Multus plugin. So we allocated these VMs into the cloud and then brought them together, created my cluster. The Multus actually, it controls, how many interfaces we have, and that is what we use for basically creating these interfaces. And then these interfaces can also be platform aware. Like if, let's say, I want a specific functionality like SR IOV, then it can give me that kind of an interface and provide that, and then the CNF can utilize that.
Okay, thank you.
So sure, thanks.
Yeah, Rajendra, one question has come in my chat section that have you deployed on any other public clouds like Alibaba, IBM Cloud, etc.?
So right now we've been primarily focusing on Google, Azure, and AWS, but we can also do the same exercise. And in fact, like if somebody is keen on contributing on that side, then you can get in touch with us and we can help you with that process. So right now, no. Besides these three clouds, we haven't focused yet.
Okay. Thank you.
Thanks.
Yeah. Any more question, please? Oh yeah, I got one more. Have you tested with any other CNI plugins?
So this particular demo that I gave, we use the Multus plugin, but in addition to that, we have also tested for it to work with the tungsten fabric from Juniper, and also from Vortex that is available. So yeah, these two are what we have tried.
Okay. Thank you, Rajendra. I will share my screen then now.
Sure. Yeah, I'll just stop sharing.
Yeah.
So thank you all for joining. It was really nice of you to take time and then attend this presentation. We look forward to see you in future presentations. Thanks a lot. Bye.
Yeah, thank you everyone. In case you have any questions regarding this webinar, you can either reach out to Rajendra or to me directly. This is our future events coming up on 8th March and 29th March. Yeah, thank you. Thank you so much for joining and taking your time out. Please do write to us for any query. We will be glad to assist you. Thank you. Thank you, everyone.
Yeah, thanks all. Thank you, Priya.
Thank you.
Bye.
Bye.
Bye.